Good morning dear students and welcome back in our video lecture with the same topic, periodic classification of elements. Student, we have discussed about doberylnitride, Mendeleev's Newland's octave, Mendeleev's periodic table, and also we have discussed about Moran periodic table. So now we are going to study about different terms in modern periodic table. In my previous video lecture, I have discussed you all points related to means how many periods are there, how many groups are there, how the arrangement of periods and arrangement in groups is related to its electronic configuration, that is atomic number. All these points we have discussed in my previous video lecture. So today we are going to study about different trends in modern periodic table. So we will discuss two trends in modern periodic table. First is valency and second one is atomic size. So we will just study it one by one. So first point is valency. So what is mean by valency? In simple word, valency is the combining capacity of an element. So this valency is related to its atomic number, that is electronic configuration. Valency is directly related to electronic configuration. Actually it is related to, or it is determined by number of valence electron in outermost shell. Students, you have studied in previous standard how to feel this electronic configuration of any element. So this valency is related to electrons which are present in outermost shell. So we will discuss with by examples magnesium. First is magnesium. You all know in my previous video lecture also I told you about shells. How many shells are there? K, L, M, N and so on. There are many shells. So electron holding capacity of K shell is 2 electrons. L shell is 8 electrons. M shell is 18 electrons. N shell is 32 electrons, and this number of electrons are depends upon formula 2m square. All these points we have discussed in my previous video lecture. So what is the electronic configuration of magnesium? Its atomic number is 12. You can see here. So in first shell 2, then 8 and 2. This is electronic configuration of magnesium. So to become stable, what does magnesium do? Students, remember this thing, each and every element either give electrons from others, either give electron to others or take electrons from other. Means it just lose or this gain electron in the surrounding to become stable. So in first stage, duplet state, at duplet state also that element is stable, and in octet state also that element is stable. So to become stable, to complete its octet, magnesium just give these 2 electrons in its surrounding. And now what is its new electronic configuration? 2, 8. Now it becomes stable. What, student? How it becomes stable? My electronic configuration of magnesium is 2, 8, 2. To become stable, any element either give electrons or take electrons. So here what magnesium will do? It just give 2 electrons in surrounding and it just complete its octet. Now 8 electrons are present in its outermost state. Now it is stable, but it becomes stable in the form of ions. Ion formation also you have studied in previous standards. So what is it becomes Mg2 plus as it gives 2 electrons. So now it is stable. So how many electrons magnesium give to become stable? 2 electrons. That's why valency of magnesium is 2. Then sulfur. Electronic configuration of sulfur is, as its electronic atomic number is 16, 2, 8, 6. Then there is limitation in giving and taking electrons. Any element can give or take up to 4 electrons only. Means here 6 electrons are present in outermost shell. So this sulfur cannot give these 6 electrons because the limitation for giving is 4 electrons, or limitation for taking is also 4 electrons. Means up to 4 electrons they can take or give. So these 6 electrons are there. So this sulfur cannot give these 6 electrons. Then how will it complete its octet, it take 2 electrons from surrounding and new electronic configuration becomes 2, 8, 8. Now its octet is complete, so this sulfur is stable. Got it, student? So it form S2 minus. That ion formations we will study later, because in previous standard we have studied this point. So how many electrons it take to become stable? 2 electrons. So valency of sulfur is also 2. Its electronic configuration is 286. To become stable, sulfur just gain 2 electrons. Its new electronic configuration is 288. So valency is 2. In magnesium, it just give 2 electrons. It lose 2 electrons to become stable. That's why its valency is 2. Then what about chlorine? Atomic number is 17. So 2, 8, 7 is its electronic configuration. To become stable, to complete its octet, it requires 1 electron. So it take 1 electron from surrounding and new electronic configuration becomes 2, 8, 8. Now it becomes stable. So how many electrons it take to complete? 1 electron. So valency of chlorine is 1. Got it, student? How valency is determined? This valency normally ranges from 1 to 4 only. Means any element having valency up to 1, 2, 3 or 4 only. Not less than 1 or not greater than 4. Only 1, 2, 3, 4. This can be valency of any element. So what happens in magnesium? Magnesium just give 2 electrons. So its valency is 2. Sulfur take 2 electrons. So its valency is 2. Chlorine take 1 electron. That's why its valency is 1. Means this valency is determined by number of valence electron in outermost shell. And what is valency? Valency is nothing but the number of electrons which are gained or lost, which are taken or given by that element to become stable. Means how many electrons that element give or take to become stable. That number of electrons is nothing but its valency. Got it, student? Now what is valency? Okay, so what happens in period and what happens in group? When you observe all the periods, what is period? Periods are horizontal lines, horizontal rows. So when you observe period, all the elements have different valencies, but that valencies ranges from 1 to 4 and then 4 to 0. Okay, and what about group? When we you observe any group, all elements in same group shows same valency. So when we are talking about group 1, all elements present in group 1 shows valency 1. Means they have same valencies. All elements in same group shows same valency because valency of all elements in group is same. Got it, student? What is valency? Valency is nothing but the combining capacity of an element. This valency is related to number of valence electrons. Valence electrons means what, student? Valence electrons means number of electrons which are present in outermost shell of that element. So valency is nothing but the number of electrons which are given or taken by the element to become stable. And it ranges from 1 to 4 only. Means any element can either give 4 electrons, up to 4 electrons, or either take up to 4 electrons only. So this is valency. In period, this valency increases from 1 to 4, means as from left to right. This valency first increases and then again it decreases. All elements shows different valencies. 1, 2, 3, 4, then again 3, 2, 1 and last 0. Because all last group 18 are inert gases. They are already stable. They do not gain or give or take any electron to become stable because they are inert gases. They are already stable. So all elements in group 18 have stable electronic configuration. They have valency 0. Got it, student? This is valency. Now we are going to study about atomic size. So what is atomic size? We have studied about structure of atom in previous standard also. What is the structure of atom? Atom is normally spherical in shape, circular in shape. At the center at the center nucleus is there. In nucleus protons and neutrons are present, and electrons are just revolve around the nucleus in different orbits. So electrons are present in different orbits, and in the nucleus protons and neutrons are present. So what is atomic size? This atomic size is related to atomic radius. Students, in maths also you have studied about how to draw circle. Means when you draw to means whenever your teacher asks to draw circle, you require its radius, and as per measurement of radius you draw that circle. As like this atomic size is related to atomic radius of that atom. Then what is mean by atomic radius? Atomic radius is nothing but the distance between center of nucleus and outermost electron, valence electron, electrons which is present in last shell. So the distance between center of nucleus and outermost electron is called its atomic radius, and this atomic size is related to this atomic radius. Now we are going to study how this atomic radius just varies in period and what happens in groups. Then this atomic radius is measured in unit picometer pm. What is picometer? Picometer is unit to measure atomic radius. Means normally we just measure any line in centimeter or meter. In greater distance we just measure in kilometer. And like this atomic radius is measured in picometer pm. 1 picometer is equal to 10 raised to minus 12 meter. Remember this unit. Okay. So how this atomic radius, atomic size varies in periods and groups, that now we are going to study. Before that I want to ask you something. Student, you all know about magnet. Suppose this is iron nail, and I just put a strong magnet near to it. Then what will happen? This nail get attracted to that magnet. Means suppose this is strong magnet and this is any iron nail or any iron rod. Suppose I just keep this magnet near to it, then what will happen? This iron nail get attracted to it. As I increase the distance, still it is attracted to it. But continuously if I am going to increase the distance, then what will happen? After certain distance, after certain limit, this nail it will not get attracted to the magnet. Why? Because of this distance, longer distance. Got it, student? First remember this. First try to understand this concept, then you will easily understand atomic radius. What I said, suppose this is magnet and suppose this is iron nail. Then as the distance is smaller, what will happen? It gets strongly attracted because there is strong magnetic force between these two. As the distance increases, what will happen? After some time, this iron nail, it will not attracted towards the magnet because of this distance. Got it, student? Now we are going to study about atomic radius. So you can see here in periods, we are just going to take examples of some elements in period. So lithium, barium, beryllium, boron, carbon, nitrogen, oxygen, all these elements are present in second period. So what is atomic number of lithium? Is 3, then B is 4, boron is 5, carbon is 6, nitrogen is 7 and oxygen is 8. Its electronic configuration is 2,1, 2,2, 2,3, 2,4, 2,5, 2,6 like this. Okay. So you can see here, for each and every element, the number of shells required for their electronic configurations are same, that is 2. Means just number of electrons are increasing, not number of shells. Means electrons are added in the same shell, that is second shell. As number of electrons, here you can see here positively charged ions are there and electrons are negatively charged ions. As the number of electrons increases, number of protons also increases. So there is strong electrostatic force of attraction between this electron and proton, because protons are positively charged and electrons are negatively charged, and you all know there is force of attraction between opposite charges. So as number of electrons increases, number of protons also increases. So force of attraction increases. Then what will happen, student? This electron experiences greater pull towards the nucleus. Means these electrons are just attracted towards the nucleus. So what will happen? As number of electrons increases from left to right, this atomic radius becomes smaller and smaller, means atomic size reduces. Why reduces? Because in the nucleus what is present? Protons are present, and these electrons are negatively charged. As these two are oppositely charged, they are attracted towards themselves. So here you can see in the period what happens? Electrons are added in the same shell. As number of electrons increases, these electrons experiences greater pull from the nucleus. That's why these electrons are just attracted towards the nucleus and size becomes smaller. That's why from left to right in period this atomic radius decreases, means atomic size decreases from left to right. Now we will see what happens in group. Here is example of first group. So in first group lithium, sodium, then potassium, then rubium, then that caesium, these elements are there. So what is atomic number? For Li3, Na11, K19, rubium Rb37 and then caesium 55. What is its electronic configuration? 2, 1, then 2, 8, 1, 2, 8, 8, 1, 2, 8, 18, 8, 1, 2, 8, 18, 18, 8, 1. So students, you can see here, as in a group, we go from top, means we just move down from top to bottom. What will happen? Here, number of shells increases, 2, 3, 4, 5, 6. Means in periods what will happen? Electrons are just added in the same shell. All elements require only 2 shells. Here what happens? Number of shells increases, 2, 3, 4, 5, 6 and so on. Then as number of shells increases, what will happen? Distance between this nucleus and outermost electron also increases. Just now I told you what happens. As the distance between magnet and iron nail increases, then after some time what happens? That iron nail not attracted towards the magnet because force of attraction decreases as the distance increases. Here same thing happens. As the distance increases, because number of shells increases, this electron experiences lesser pull from the nucleus. It is not strongly attracted towards the nucleus. That's why atomic size, atomic radius just increases as you move down to the group. Means atomic size increases down the group. So I hope you got all points related to this atomic size. What happens in period? Atomic size just decreases from left to right. And what happens in period? As we move down the group from top to bottom, this atomic size just increases. Got it, student? What is atomic size and what is valency? I hope you got all points related to trends in modern periodic table, valency and atomic size. Both points are very easy to understand. So just try to understand these points. If you have any doubt, you can ask me. Thank you.